Hello again out there in remote learning land. Today's hot topic, longitude and time. Yesterday we talked about Polaris and latitude. Today we're going to talk about time and longitude, right? We talked about time zones briefly and a little bit about the coordinate system, but today you can actually see how the time zones can help with longitude, and longitude can help with the time zones. You can go either way. All right. Hopefully you put some good effort on those prologue do now questions, folks. Those are all region-style questions, and the more you see them, the more vocabulary you're exposed to, the better you'll end up doing. So please put some effort in there. Also, don't forget progress reports. I'm going to be working on those this week. Make sure you have any incomplete labs, polished up and submitted, and all your lessons. Make sure they're completed and submitted. Okay. All right, I want to start out with a little clip. This could happen to any one of us, a confused traveler. He's traveling different time zones, and I guess he gets a little mixed up. Watch carefully.
Sorry.
My watch is off by an hour. Should I change it?
You came from New York, so yeah, you need to go back an hour through Central Time.
I don't know. I'm watching him right now. He's buying his ticket. He arrives in Vegas at 10 tomorrow morning, okay?
Okay, I'll be there.
Where you headed? Where you headed?
Las Vegas.
Not from here, you ain't. Not tonight. Let me see your ticket. What time you got?
5 to 11. Well, the ticket office said that there was a bus going to Las Vegas, Bay 3 at 11 o'clock.
Well, now, all we know for sure is that your watch ain't being completely honest with you. There was a bus at 11, but now it's done at 12. Where you just come from?
New York, Chicago, Denver.
Seems like you put your watch back one too many times, my friend. There ain't no way you're gonna catch a bus and left you an hour ago.
There's no other bus.
There's no other bus. Not this time of night. There's a truck stop 100 yards up the road. If you're lucky, you might pick up a lift and catch a night train.
Okay, thank you.
All right. So yeah, I could see that happening to me. He was going from New York to Vegas, right? So he had to skip a couple of time zones, and I guess he must have had a layover with a flight or whatever it was, and he messed up his time. It does get a little confusing as you travel toward California, right? As you travel to the west, we say time gets less. So you have to turn your watch back. Well, he did it one too many times, ended up missing his bus. So how does longitude determine time anyway? Well, it's all about the rate of Earth's rotation. You got to look at it this way. The equator is like a circle, 360 degrees, and the Earth spins once in 24 hours, 360 degrees in 24 hours. So if you do the math, 360 divided by 24 is 15 degrees per hour. And that's why every time zone is 15 degrees. So if you travel 15 degrees worth of longitude, you have to change your watch an hour. Okay? Solar time is based on the prime meridian. Make sure you get this in your notes. Sometimes it's called Greenwich Mean Time, but it's just basically that time in Greenwich, England. And that's the place where they actually sat down for the conference to determine and set up the time zones. And that's why they started there, because the conference was held there. Okay? Prime meridian divides east from west, right, as does the international dateline. But for longitude, we're going to always measure from the prime meridian. Okay? Rotation, obviously, spinning on an axis. It does it once in 24 hours. Earth rotates, as you can see, from west to east. So these people are always going to be a little ahead of us. These people are always a little behind us. All right? 360 degrees every 24 hours, of course, like we said, turns out to be those 15 degrees per hour. And that's why the time zones are 15 degrees. Okay? Here is the time zone map of the United States. We live over here, right? Everybody knows we're in Eastern Standard Time. If you're a big sports person and you watch games on different coasts or different parts of the United States, the broadcast will tell you what time it's on, but then it'll tell you what time zone it's in, or of course you will miss the game. So Frank, the guy in the video, he flew from New York to Chicago, so he should have set his watch back an hour. And then he was flying Denver, right? But then he was going into Vegas. So instead of setting it 2 hours back, he set it 3 hours back, or whatever the scenario was there. He ended up missing his bus. So now as I go here, so that's 1 hour, 2 hour, that's 3 hours. Even though it's 4 time zones total, you would change your watch 3 hours because you're already here. So 1, 2, 3 hours earlier. Okay? Go the other way. Let's say you start out in California. Now you got to go 1, 2, 3 hours ahead. Okay? And it's kind of funny because when you're on a plane, the winds in our country blow this way, and they blow at very high speeds in the upper atmosphere. So the plane traveling from California to New York will actually go a little faster. It has a tailwind, and it'll push it. And it'll land, the flight will actually be about an hour shorter. And if you're flying from New York to California, you're fighting that headwind. It takes you about an hour longer. So now add that into the mix and it gets real confusing. But forget wind, we're just talking about time zones. Every time you go about 15 degrees, you have to change another hour. All right? This classic diagram here I sent you the other day. When you go west, time gets less. When you go east, time increased. Right here, you subtract an hour. It gets west. Here you add an hour, it increases. Okay? Notice they're separated by 15 degrees, and this will be in your notes, obviously. So every 15 degrees is a new time zone, is another hour. All right, we're going to reference this when we try to work out times. I'll do the first one with you, and then you guys are on your own, and we'll meet back in the meet to see how you did. So for the first one, this is the longitude of where you are, right? So maybe you want to write in there, this is your longitude. This is England, right? The prime meridian. And this is your time, right? So the chart's a little strange, but this is where you are, this is your time. So now, if it's 5 o'clock in England, and you're at 30 west, well, what time is it where you are? Well, 30 west, remember it's 15 degrees per hour. So the first thing you do is say, all right, 30 divided by 15 is 2. It's going to be a 2-hour difference. Now, if you are west, time gets less, so you would go 2 hours earlier and you would get 3 p.m. All right? I'll do one more with you going the other way, and then I'll really leave you on your own there. So now it's 2 a.m. in England. Where you are, it's 6 a.m. Now it wants to know what your longitude is. Well, 2 a.m., it's 6 a.m. by you, so that's 4 hours later, right? Time increased by 4 hours compared to England. So now, 15 degrees per hour, it's a 4-hour difference. 15 times 4 is 60. So it's got to be a 60 degrees, and it was later, so you got to be toward the east. And that's how you get 60 degrees east. All right? So it takes a little thinking, right? Don't get frustrated, right? Take your time, complete this chart. And, of course, there's another chart on the next slide. We'll go through all those. Take about 5 minutes or so. All right? I'll meet you in the meet.